When we think of robots, we usually picture rigid, pre-programmed machines doing exactly what a line of code tells them to do. But at the recent NVIDIA GTC event, CEO Jensen Huang was joined on stage by someone unexpected, Disney's Olaf. And here is the crazy part. Olaf wasn't following a pre-programmed animation. He was walking, reacting, recovering from stumbles, and expressing himself completely autonomously. This breakthrough is a collaboration between Disney Research, Walt Disney Imagineering, and NVIDIA, three powerhouses merging physical engineering with cutting-edge machine learning. But how do you teach a machine to move with the wobbly, clumsy charm of a magical snowman? The answer lies in how our brains process expectations and how robots can simulate an entire lifetime of learning in just 48 hours. Sketching the brain, Newton, Camino, and toddler physics. To understand Olaf's brain, we have to look at how humans learn. When a toddler learns to walk, they use trial and error. They take a step, they fall, their brain registers the physics, and they try again. This is driven by our brain's reward pathways, specifically dopamine reinforcement loops. Disney Research and NVIDIA used the exact same concept, but in code using deep reinforcement learning. Instead of hard coding every joint movement, they dropped a digital Olaf inside NVIDIA Isaac sim inside the Omniverse platform. The physics of this virtual world are governed by the Newton engine, an open-source physics solver co-developed by NVIDIA and Disney Research, with Camino serving as its GPU-accelerated back-end solver. The neural network was given a simple goal: walk forward without falling. Now here is where it gets extraordinary. Because this training runs in massively parallel GPU simulations, Olaf didn't train for years. He trained for approximately 2 days on a single NVIDIA RTX 4090. In 48 hours, he experienced more falls, recoveries, and physics lessons than a human toddler could accumulate in a lifetime. The physical body, edge AI, and actuator chaos. But physical physics is one thing. The real world is messy. This is what NVIDIA calls physical AI. Olaf's physical body is powered entirely by the NVIDIA Jetson Edge AI compute platform. He isn't relying on a giant server rack backstage. All the processing happens right inside the snowman. And this is where engineering gets incredibly difficult. In the real world, Olaf has to balance on unpredictable terrain while managing a unique hardware challenge: heat. Every time those internal actuator motors fire, they generate intense heat, especially concentrated in his slim neck design. The AI policy isn't just balancing his weight, it actively reads temperature sensor inputs from his own joints and uses them as part of its reward function, deciding how to move efficiently to prevent overheating. In other words, Olaf literally feels the heat and adjusts his own behavior to survive it. The psychology angle, predictive coding, and the uncanny valley. But why Olaf? Why not a sleek humanoid robot? This is where cognitive neuroscience tells a fascinating story. As humans, our brains are constantly making predictions about the world. This is called the predictive coding framework. Your brain is essentially a prediction machine, always anticipating what comes next based on past experience. When we see a robot that looks almost human but moves unnaturally, our frontal cortex fires a predictive coding error, a mismatch signal between what we expected to see and what we actually got. This cognitive dissonance makes us feel deeply uncomfortable. We are wired to trust humans, and something that mimics us imperfectly feels threatening. This is the neurological engine behind the uncanny valley. Disney sidesteps this entirely by choosing Olaf, a highly exaggerated, cartoonish character. Our brains never even attempt to categorize him as human, so there's no prediction to violate. Instead of triggering discomfort, his clumsy, dynamic, AI-driven movements trigger something else entirely: empathy. We perceive his wobbly nature as vulnerability and authenticity. We don't see a terrifying, autonomous machine, we see a friendly, fragile snowman who's trying his best. This autonomous Olaf is set to debut at Disneyland Paris World of Frozen on March 29, 2026, interacting with guests in real time. It's a massive leap forward, where edge computing, deep reinforcement learning, and cognitive psychology blend seamlessly. What do you think about AI interacting with us in theme parks? Will your brain's predictive coding system flag him as something strange, or will you just want a warm hug? Let me know in the comments below. If you loved exploring the psychology behind this tech, hit subscribe. We'll keep sketching out the future at Cortex and Code together.